Hello students, welcome to NewtonGATE Academy and welcome back to my another video. In this video, I am super excited. Why? Because as you know from thumbnail that I'll cover this year, 2021 JEE Advanced question discussion. It is paper 1 question discussion here. In paper 1, it has 4 sections, number 1, number 2, number 3 and number 4. And in number 1 section, it has 4 questions, and this is number 1 question, and each question carries plus 3 marks for correct answer. For wrong answer, it is minus 1 to be deducted, and not attempt, it is 0. Okay, so let's start our first question from unit and dimension. Okay. The smallest division on the main scale of a vernier calipers is 0.1 centimeter. Okay, like this is a vernier calipers where you can measure any diameter, any small length. This is main scale and this is vernier scale. You know, in practical classes, this is the vernier calipers. Okay, this is a vernier calipers. Okay. So the main scale reading is given here, that is 0.1 centimeter. Okay, 0.1 centimeter, that is on small scale division like this, 0.1, 0.1, 0.1 like this. That means 1 millimeter. Okay, this is 1 centimeter, 0 to 1 centimeter. Right. That is given is the 10 division of the vernier scale correspond to 9 division of the main scale. That means 10 division of a vernier scale is equals to 9 division of main scale, right? That is 9 MSD main scale division, which equals to 10 vernier scale division, that is VSD, that is given. And from this data we can easily calculate what? List count, right? The list count of the vernier scale, right? The figure below on the left shows the reading of the calipers with no gap between its two jaws. Whenever we not measuring anything, any length, any diameter, whatever, the main scale reading 0 should be equals to vernier scale reading 0. That should be coincide with each other. But here, first diagram, that is left side diagram, is given here. In this diagram, the reading is shows. That means the main scale reading is 0 and this is vernier scale reading, and there is something gap is given here. This gap. Okay, that means you know better, that means zero error is present here, right? Okay, this data is given. Now the right figure shows, that means this figure, it shows the reading of a solid sphere held between the jaws. That means whenever you measuring something, suppose this is a sphere, solid sphere, we want to find the diameter of this solid sphere. Okay, so there is something we can get some reading. This is the reading, this given. That means the diameter, whenever we want to measure some diameter, the reading is given here. Actually, they asked you that you just find the diameter of the sphere, this sphere. The reading is given. This is so easy. But the main key point of this question is, just remember or just think about it. The main key point is this portion, this reading. Because as we know that for simple, you can easily find the reading of this data. We can easily find the data from this reading, because here main scale reading is 3 and this is 0.1, that is 3.1. Plus you can easily find vernier reading into list count. This is our answer. But here 0 error is present. You have to find 0 error first, then you can find this part, because here plus minus 0 error is, you have to add or subtract. Just you have to know what is the positive 0 error or negative 0 error, right? Okay, so first you have to find list count first. So here the data is given, the 9 MSD, that is 9 main scale division, that is 1, 2, 3, 4, 5, 6, this is 9, this is 9 and this is 10, that is 1 centimeter and 9 in what? In millimeter. So 9 main scale division is coincide with 10 vernier scale reading. That means 1 main scale division is 10 by 9 vernier scale division. Or you can say 1 VSD equals to 9 by 10 main scale division, right? So now what is least count? Least count is the gap, that is one least count, or least count means, simple least count means one main scale division minus one vernier scale division, right? One main scale division minus one vernier scale division. So just put over here, one main scale division is simple, the data is given 0.1 centimeter, but one vernier scale reading means like this, 9 by 10 main scale division. Clear? So 0.1 centimeter minus, okay, first you have just put one main scale division, right? 1 minus 9 by 10 into main scale division, which equals to 1 by 10 main scale division. That means 0.1 main scale division, and that main scale division reading is given here, that is 0.1 centimeter. That means 0.1 into 0.1 centimeter, that means 0.01 centimeter. This is the value of least count of the scale, right? Clear? In millimeter that should be 0.1 millimeter, right? तो पहले इसका डेटा मत पुट करो, 1 minus this, then you can just put one main scale reading, that is one main scale division is 0.1, just put over here, you can get least count, right? So least count is given, and easily you can remember because in this book, in your book, they given the 9 main scale division is equals to 10 main scale division, and you can get a least count value is always 0.01 centimeter or 0.1 millimeter. Clear? This is so easy. Now you have to find, this is our least count. So least count is 0.01 centimeter. So the answer is all are given in centimeter, that means your least count should be in centimeter, that should be better. Okay, now zero error, find zero error first, because from this data you can simply find the value of the diameter, but you have to calculate first zero error. That's why this reading is given. So here you can see the main scale is 0, main scale reading 0, and the vernier scale reading, in vernier scale the 0 is the left side of this main scale, right? Then 1, then 2, then dot dot dot. Okay, and another case, whenever main scale is here and vernier scale 0 is here. Okay, this is main scale division, this is vernier scale, main scale division, this is vernier scale. Okay, so this is the two condition here, and another condition, whenever main scale 0 and vernier scale 0 are coincide with each other, then in this condition we can say that is no error. This is our suitable condition, that main scale 0, main scale reading MSD, main scale reading, that means 0, the first reading is 0, and vernier scale reading 0 should be coincide. But here the given data, in this given data, the main scale 0 and vernier scale 0 is not coincide here. That means error is there. So what is the error? So this condition is present. For this condition we can say the positive error. Whenever we say if vernier scale 0 is the right side of the main scale 0, we can say the positive error. The vernier scale 0 is left side, that means this side, left side of this main scale 0, we can say that is negative error. Negative, right? So whenever we calculate the accurate data, you have to, whenever you get the negative error, you have to add this data with main scale data, or if you get positive error, you have to subtract it from this main scale data. Clear? So here negative, how to find what is this is negative error or positive error? You have to check the main scale 0 and vernier scale 0. If vernier scale 0 is left side of the main scale 0, then negative error is here, and if main scale 0 is if the vernier scale 0 is right side of the main scale 0, you can get positive error. And whenever we get positive error, we just subtract it from the main scale reading, and whenever we get negative error, we just add it from main scale reading. Clear? Okay. And why is subtract? Why it added? So the theoretical part. You can just join our theory classes. We'll discuss in better way. Okay. Now, the zero error. Just find the zero error. That is, main scale data is here 0, 1, 2, 10. That means this is the 1 in millimeter scale, that is 10 millimeter. And vernier scale reading is here, that is 0, and so on. Okay. So how to find main scale reading? How to find main scale reading? How to find main scale reading? Main scale reading, we are finding that in this way, that whenever vernier scale 0 crossed the reading, we just find main scale reading. जो स्केल को वर्नियर स्केल रीडिंग, वर्नियर स्केल 0 क्रॉस करेगा, अगर इसको क्रॉस करेगा तो ये होगा मेन स्केल रीडिंग, अगर इसको क्रॉस करेगा तो ये होगा मेन स्केल रीडिंग. दैट मीन्स व्हेनेवर वर्नियर स्केल 0 क्रॉस some reading in main scale, that should be the main scale reading. Here vernier scale 0 doesn't cross main scale 0 also. That means what should be the main scale value in this data? What should be the main scale value? Because as we know that the main scale reading should be whenever the 0 of the vernier scale cross that reading. But here vernier scale 0 doesn't cross even the 0 of the main scale also. That means before 0, that should be the -1. Just imagine, that should be the -1, then -2 in main scale reading. Okay, so that means for 0 error, whenever we find 0 error, which equals to 1 main scale reading plus what? Vernier scale reading into least count, and we know the least count as we find it 0.01 centimeter or 0.1 millimeter. So here -1 in millimeter, that is say that is 10 millimeter. In centimeter that should be 1 centimeter, but in millimeter that is 10 millimeter. That means it is 1 millimeter, 2 millimeter, this is 1 millimeter, 2 millimeter, 3 millimeter, right, like this. And in centimeter that is 0.1 centimeter, 0.2 centimeter, like this. Okay, so one main scale reading is given here, that is, as we know that the 0, just think about it, the 0 is just crossed -1 of the main scale reading. That means main scale reading is -1 plus vernier scale reading. What is the vernier scale reading? Vernier scale reading means whenever vernier scale just matched with main scale. That means here this match is like this, here that is 6. Just check all the vernier reading 0 to 10. Whenever any reading is just matched with main scale, that should be the vernier scale reading. Here 0 is not matched with 0, 1 is not matched, this is 2 is not matched, 3 is not matched, 4, 5 is not matched, slightly different. Here you can see the vernier in vernier scale 6, 0, 1, 2, 3, 4, 5 and 6, this is 7, 8, 9 and 10, right? So this 6 is just coincide with the main scale reading, right? This 6 is just coincide with 7 is not, 8 is not, 9 is just one reading, that is 6 is just coincide. That means this is our vernier scale reading, that is 6 into least count is given here. All the data in millimeter, that means least count should be just put in millimeter, 0.1. Okay, that means -1 plus 0.6, that means minus 0.4, this is millimeter. This is our 0 error. That means this value is 0.4 millimeter. This is the gap. Okay, and you can see the negative sign is here. That means this is negative 0 error. Okay, and as we know that whenever we get negative 0 error, we just add it in the main scale reading to get accurate result. Okay, so our 0 error is 0.0 error is minus 0.4 millimeter, right? Now what is the correct diameter of the sphere? The diameter reading is, now this scale part is over. Now this, okay, here the reading is given, that is the value of diameter is given here, that is main scale reading is 3, and now you can just find the diameter, the normal diameter. diameter. That means 0 of this vernier scale just crossed 3.1. That is 3.1 centimeter is given here, right? This is 3.2, this is 3.4 in centimeter, or in millimeter that should be another reading. This is the centimeter scale, right? 4 centimeter, this is 3 centimeter. That means this is 3.1 centimeter. So main scale reading, main scale division plus vernier scale division into least count, or main scale reading PSR, MSR, main scale reading what? 3.1, because as we know that main scale reading what? The vernier scale 0 just crossed the value, that means 3.1 centimeter just crossed, okay, the 0 of the vernier scale, that is 3.1 centimeter plus actually vernier scale reading. You can see here that the vernier scale reading, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, only 1 is coincide with main scale reading. Only 1 is coincide with main scale reading, not 2, not 3, not 4 and up to 10. Only 1. So that means vernier scale reading should be 1 into least count. This is put it in centimeter, that means you should put least count in centimeter, because vernier scale reading it has no unit. So whenever you put least count in centimeter, then you can get this reading in centimeter. Whenever you put least count in millimeter, then you can get least count in this reading in millimeter. So here I want to find in centimeter, the main scale reading is also centimeter, that means least count should be 0.01, that's why this is centimeter. So you can get 3.1 plus 0.01, that means 3.11 centimeter. But this is not our actual diameter, because due to presence of zero error, we this data is the not accurate data. Okay, so you have to find the accurate data, that is accurate diameter, which equals to diameter or main scale whatever this reading, diameter plus minus zero error. Here negative zero error, that means you should add it, okay, this data without putting negative sign, or you can just in generalized form you can just put negative, diameter into negative zero error. For positive you can also put in this equation, for negative zero error you can also put in this equation. So diameter is given here, that is 3.11 minus, just put with sign, minus 0.04. This is in millimeter, so for centimeter this is 0.04 centimeter. Okay, that means we can get our actual answer, that is 3.11 plus 0.04, that means 3.1, that is 4.5 centimeter, right? So this is our actual data of the diameter. Okay, just remember this part. Whenever you get negative sign, that means negative zero error. Whenever you get positive sign, that is positive zero error. For positive zero error, you should subtract that error from this data. Whenever you get negative zero error, you should add this error from in this data. But here, if you put with sign, just remember this formula: the data minus zero error. Whenever you will get negative zero error, that means negative should be positive, that means automatically added. And whenever you get positive zero error, that means this part should be positive, so automatically it will subtract it from this data. So that's why this is our general formula, you can just remember it. Okay, so this is our first question. So go to our next question. Okay, this is next question, paper 1, section 1. An ideal gas undergoes a 4-step cycle as shown in the figure. PV diagram here, that is P and B, the 4 cycle. Say this is one cycle, A to B, then B to C, then C to D, and then D to A. During the cycle, heat absorbed by the gas in. Okay, so during the cycle, suppose A to B, B to A, C to D, and D to A. During this cycle, कौन से स्टेप में, सपोज स्टेप 1, स्टेप 2, स्टेप 3 एंड स्टेप 4, कौन सी साइकिल में हीट एब्जॉर्ब हुआ है बाय द गैस, हीट एब्जॉर्ब्ड बाय द गैस, राइट? ओके, सो ऑप्शन इज देयर, स्टेप 1, स्टेप 2, स्टेप 3, स्टेप 1, स्टेप 3, स्टेप 1 एंड स्टेप 4 एंड स्टेप 2 एंड स्टेप 4. ओके, so first we go for step 1, that is whenever gas goes from A to B. Okay, suppose for this type of question, you just think, or you can just imagine a cylinder like this. Okay, this is a fixed cylinder, or it has a fixed piston like this. Okay, it contains ideal gas. Right? Okay, so in first step, whenever this gas is undergoes from A to B, that is in step 1. In step 1, you can see pressure is constant. In this part, the pressure is constant, but volume is increases from this to this part, so P1 to V2, like this, and say this is P1 to P2. So for step 1 only, just think about this. Just step 1, A to B, pressure is constant, but volume is just from this to this, V1 to V2. अगर so A to B गया है तो V1 to V2 हो गया. That means volume is increases. So what happens? Pressure is constant, volume is increases. That means P is constant है, V increases. That means this piston goes to or goes rise like this. Okay, like this. Okay, volume increases, volume rises, and pressure constant. So what happens? So just think about it. एक गैस था, उसमें प्रेशर कांस्टेंट करना है, लेकिन वॉल्यूम इंक्रीज करना है, तो क्या करेंगे? Whenever we just increase the temperature, अगर मैं इसका टेम्परेचर इंक्रीज कर दूँ, राइज कर दूँ, इसका जो इंटरनल टेम्परेचर है उसका अगर राइज कर दूँ, बाहर से टेम्परेचर देकर या कुछ भी करके अगर इसको टेम्परेचर दे दूँ, तो क्या होगा? एक्सपेंड करेगा, एक्सपेंड करने के लिए चाहेगा. ओके, राइट. तो दैट्स व्हाई वॉल्यूम इज इंक्रीज, बट प्रेशर इज कांस्टेंट. दैट मीन्स मैं इसका वॉल्यूम ऐसा इंक्रीज कर रहा हूँ कि प्रेशर कांस्टेंट रहे अंदर में और वॉल्यूम इंक्रीज करें ओनली. सो यू द गैस टेम्परेचर शुड बी इंक्रीजेस. राइट, अगर इंक्रीज नहीं करेगा, अगर गैस तो वर्क कर रहा है ना यहाँ पर, द वर्क डन बाय द गैस. सो इफ टेम्परेचर इज डिक्रीजेस, तो गैस वर्क तो नहीं करेगा ना. टेम्परेचर वॉल्यूम इंक्रीज करना है, प्रेशर कांस्टेंट रखना है, सो टेम्परेचर शुड बी इंक्रीजेस. दैट मीन्स अगर वर्क डन फाइंड करें, W equals to P into dV, the change in volume, that means P is constant here, dV is positive here because volume increases. That means W is positive here. The work done by the gas is positive, right? Now internal energy del U, due to temperature is increases, that means del U, that means F by 2 N R del T, right? So del T is increases, that means this del T is positive, that means del U also positive, this is also positive, right? So using the first law of thermodynamics, that means del Q, that means the heat absorbed or rejected by the gas, which equals to del U plus W. W is positive, del U also positive, that means del Q is also positive. This is mathematically. But if you think that for rising this volume, the temperature should be increases in the, that means the internal energy of the gas should be increases, because अगर हम वर्क करना चाहेंगे, हमारा अंदर तो एनर्जी होना पड़ेगा ना. अगर एनर्जी नहीं रहेगा, पहले जैसा रहेगा, तो ज़्यादा वर्क नहीं कर पाएंगे. अगर एक्स्ट्रा में वर्क कर रहा हूँ, दैट मीन्स एनर्जी इनसाइड मी शुड बी इंक्रीजेस और पॉजिटिव. दैट मीन्स हियर हीट del U is positive, that means heat is what? Absorbed by the gas. अगर हीट बाहर से, अगर हीट आइडियल गैस एब्जॉर्ब नहीं करेगा, तो इसका इंटरनल एनर्जी कैसे इंक्रीज होगा? इसके अंदर तो हीट का सोर्स नहीं है, तो बाहर से तो टेम्परेचर लेकर वो बाहर से हीट लेकर टेम्परेचर राइज करेगा. तो दैट मीन्स हीट शुड बी पॉजिटिव. सो इन स्टेप 1, so our question is the heat absorbed by the gas in which step heat should be absorbed by the gas. So here we can see heat is absorbed by the gas. That means step 1 is positive. Step 1 is right answer. That means here all the options, these 3 options, 4 तो नहीं होगा because यहाँ पर 2 and 4 है. तो step 1 and step 1. So in step 1 heat should be absorbed. Okay, by doing this work. Now in step 2, that is gas goes from B to C in this path. Here you can see pressure is decreases from P2 to P1 हो गया, B to C. In this journey B to C, pressure is decreases, V is constant here, because here V2 is constant in this path, B2C. V is constant here and pressure is decreases. Now just think, अभी तो ये पिस्टन यहाँ पर ही है, यहाँ पर ही है, वॉल्यूम इंक्रीज होकर हो गया, वॉल्यूम तो जो है, लेकिन अभी वॉल्यूम कांस्टेंट है, प्रेशर को हम डिक्रीज कर रहे हैं, मतलब इसके अंदर जो प्रेशर था उसको डिक्रीज कर दो, लेकिन गैस को क्या करना पड़ेगा? अगर प्रेशर को डिक्रीज करना तो गैस क्या होगा, अंदर में गैस क्या होगा? तो गैस क्या होगा, गैस का जो फोर्स दे रहा था इसका वॉल में, प्रेशर मतलब क्या है? फोर्स पर यूनिट एरिया. सो दिस फोर्स पर यूनिट एरिया शुड बी डिक्रीजेस. दैट मीन्स गैस का जो इंटरनल टेम्परेचर है वो डिक्रीज करना चाहिए. तो गैस को क्या होना चाहिए? कंप्रेस होना चाहिए. तो गैस कब कंप्रेस होता है? अगर गैस का टेम्परेचर डिक्रीज हो जाता है तो गैस कंप्रेस हो जाता है ऑटोमेटिकली. अगर टेम्परेचर राइज करोगे तो गैस एक्सपेंशन होता है, अगर गैस का टेम्परेचर डिक्रीज करोगे तो गैस कंप्रेस हो जाता है. तो मैथमेटिकली मत सोचो, पहले सिंपल फिजिकली सोचो कि एक सिलेंडर है, उसका वॉल्यूम कांस्टेंट है लेकिन प्रेशर डिक्रीज हो रहा है, मतलब गैस ठंड पड़ रहा है, गैस का जो वॉल्यूम जो प्रेशर था अंदर में वो कम हो रहा है, मतलब गैस का जो टेम्परेचर वो डिक्रीज हो रहा है. दैट मीन्स डेल क्यू शुड बी नेगेटिव, बिकॉज हीट जितना हीट था गैस में वो बाहर कर रहा है. दैट मीन्स हीट रिजेक्टेड बाय द गैस. नाउ यू कैन थिंक इन मैथमेटिकली. दैट मीन्स P is decreases, V is constant. That means W equals to P into del V. That is change in volume here. V is constant. That means change in volume is 0. That means W is 0. So work done by the gas is 0. Now del U, that is internal energy. That is F by 2 degrees of freedom by 2 nRT. That means del T. Right? So this del T is negative because due to pressure decreases, volume is constant. So this temperature should be negative. That means del U should be negative. Del U should be negative. That means internal energy of the gas should be negative. So del Q equals to del U plus W. W is 0 here. That means del U is negative. That means del Q should be negative. That means heat is rejected by the gas. That's why the temperature of the gas decreases, and that's why pressure by the gas in this cylinder, on the cylinder, is decreases. So in this process, तो heat तो absorb नहीं कर रहा है गैस, heat reject कर रहा है. तो नंबर 2 जो है, तो ये वाला ऑप्शन देखो नंबर 2 है, ये तो नहीं होगा. स्टेप 1 राइट है, लेकिन इन स्टेप 2 heat is rejected by the gas, not absorbed by the gas. Okay. Now just try from yourself step 3, C to D. Whenever this gas goes from C to D. So in this process you can see, in this process whenever gas goes from C to D, here pressure is constant. Just think, pressure is constant in the given data, pressure is constant, volume is from C to D, volume is decreases from एरो देखो C to D. दैट मीन्स वॉल्यूम इज डिक्रीजेस. दैट मीन्स ये जो पिस्टन था इसका वॉल्यूम ज़्यादा था तो ये डिक्रीज हो गया, पहला जैसा हो गया ऐसा. यहाँ पर गैस नहीं है, वॉल्यूम डिक्रीज है. तो अगर किसी चैम्बर में गैस है, अगर उसका वॉल्यूम डिक्रीज करोगे तो प्रेशर ऑटोमेटिकली इंक्रीज करना चाहिए, राइट? पहले यहाँ पर पिस्टन था, उसका वॉल्यूम अगर डिक्रीज कर दो तो प्रेशर तो इंक्रीज होना चाहिए, लेकिन यहाँ पर कह रहा है कि प्रेशर इज कांस्टेंट. C में जो था D में भी वही है, the same pressure at C and at D. That means pressure is not increased here. That means P is constant here and V is decreases. That means negative. V is negative. That means decreases, and pressure should be increases. But here pressure is constant. That is given. That means temperature of the gas should be decreases, because temperature, if the temperature of the gas rises, then pressure should be rises, right? If volume of the cylinder is constant, just give you a situation. Volume of the cylinder is constant. If temperature is rises, then pressure automatically rises. But here pressure is constant and volume is negative. Pressure is constant, volume is negative. That means volume को और छोटा करते जा रहा है. वॉल्यूम नेगेटिव मतलब पहले जो वॉल्यूम था उससे भी कम, तो प्रेशर तो ऑटोमेटिकली इंक्रीज होना चाहिए, लेकिन प्रेशर कांस्टेंट है. पहले यहाँ पर जो था उसमें भी प्रेशर जितना था वॉल्यूम कम कर दिया उसमें भी प्रेशर उतना ही है। दैट मीन्स टेम्परेचर तो इंक्रीज तो नहीं होगा, सेम भी नहीं रहेगा, और भी कम हो जाएगा। तो वॉल्यूम अगर गैस का टेम्परेचर अगर कम होता जा रहा है तो मतलब क्या है, गैस कंप्रेस हो रहा है, ठंड पड़ रहा है, गैस कंप्रेस हो रहा है। तो इसलिए क्या होगा, हीट तो नेगेटिव ही होगा। तो मैथमेटिकली देख लेते हैं, W इक्वल्स टू P इंटू डेल V है, डेल V इज नेगेटिव, दैट मीन्स नेगेटिव P dV। तो W तो नेगेटिव है, वाई नेगेटिव, बिकॉज वॉल्यूम डिक्रीज हो रहा है, V2 माइनस V1, दैट मीन्स दिस पोर्शन इज नेगेटिव बिकॉज V2 नाउ फाइनल वॉल्यूम इज V1 एंड V2, this volume is less, that means this is negative, that means work done is also negative. And del U, internal energy also decreases because del U is proportional to del T. The temperature is decreases in this situation, that means del U also negative. So del Q equals to negative del U plus W. Del U is negative here and W is also negative here, that means del Q is 100% negative. That means heat is rejected by the gas. In this condition also, from D to C, in this process heat is rejected, okay, rejected by the gas, right? So this is a 3 condition. Condition 3, D to C, heat is rejected, so not heat absorbed in this process. So this is not true. So only option C is remaining, that means this is our right answer, okay? So for option C here 1 and 4 is in step 1. तो step 1 तो हमने देख लिया, तो step 4 को देख लेते हैं। step 4 में क्या हो रहा है, okay? So in step 4 D2A, that is the process here, that is D2A. In D2A volume is constant because you know this is the portion, that is volume is constant, only pressure is rises. So V is constant here and P is positive, that means it rises. So whenever V is constant, that means work done is 0, P into del V, that means 0, V is constant. So physically अगर देखो, पहले think, then you can go for mathematically. Now in this condition, at point D, this is our present condition. Whenever we go to A, V is constant, that means the volume, that is this piston is at the same position, the volume is constant, this chamber, the portion is constant, but pressure is rises. So the pressure exerted by this gas on the area of the cylinder is rises. That means the force is rises by the gas, that means pressure is rises in the cylinder. That means only condition is whenever the temperature is increases, that means del Q should be positive, right? तो मैथमेटिकली देख लेते हैं, del U, W तो 0 है, del U equals to F by 2 N R del T, and del T is positive because pressure is rises, that means del U is positive. So del Q equals to del U plus del W is 0 here, del U is positive, that means del Q is also positive, right? Okay, so this is the condition where, so we just our conclusion is D2A, from this process D2A, pressure constant, pressure rises, volume constant, that's why gas is absorb heat to increase the pressure, right? So option C is right answer because in step 1 you can see here the heat is absorbed by the gas, and in step 4 also the heat is absorbed by the gas. अगर क्वेश्चन में ये होता कि heat is rejected by the gas, so in this process B to C in step 2 and in step 3 only, in these two process heat is rejected by the gas, and in process 1 and 4 heat is absorbed by the gas, right? Okay, clear? If you have any doubt or any further discussion, you can just write in the comment section. Okay, so go to our next question. So question number 3. An extended object is placed at the point O. So here this is the O point, you can see, and this is the extended object, not a point object. Just remember, this is the extended object, right? So और भी extended कर लेते हैं like this, the extended object. 10 centimeter in front of a convex lens. So this is our convex lens, this is first lens, this is L1 and is placed 10 centimeter from this convex lens L1, and a concave lens L2 is placed 10 centimeter behind it. Behind it matlab behind this L1 lens. This is the second lens, that is L2, and the distance is 10 centimeter, that is given as shown in figure. The radius of curvature of all the curved surface in both lenses are 20 centimeter, right? The radius of this curvature, that means this is R1, say, for this curvature, for this curvature, for this curvature, for all the lenses, so both lenses, for convex lens, for concave lens, the radius of curvature, that is R, should be all for all equal, that is 20 centimeter. Now the refracting index of the lenses are 1.5 is given. This is 1.5, and the total magnification of this lens system. So this is the system, that is L1 and L2 are present here. For this system, the total magnification you have to find. So first find magnification due to first lens, that is L1, then find magnification due to L2, then you can find the total magnification, that is total magnification formula, as we know, that M1 into M2 for two lens, that is 1 and 2, M1 into M2. So you just finally you can apply this formula, you can get total magnification. So this magnification M1 is for lens 1 and M2 is for lens 2. So just this is a very simple problems for JEE Advanced. तो JEE Advanced का लेवल जितना है, ये क्वेश्चन तो बहुत ही सिंपल है, ये जॉइंट में भी आ सकता है और नीट में भी आ सकता है, वेरी सिंपल क्वेश्चन है, बट कैलकुलेशन थोड़ा सा ज़्यादा है. सो जस्ट राइट फ्रॉम योर सेल्फ फर्स्ट and write your answer in the comment section, like option A, that is 0.4, 0.8, option B 0.6 is 1.3, and in option D, that is 1.6. okay, just try. So first here object is O is placed here, object O is placed here. So for first lens object is this one, but for second lens object is not O. So just forget about lens 2. Just first think about lens 1 only. So for this lens, that is for L1, object is placed at O. So you have to find image first, then you can find M1, that is magnification, that is V by U, the image distance divided by object distance. Okay, so to calculate, because U is given here, that is 10 centimeter, but V is not given. So to calculate V, you have to find first, you can use this formula, lens formula, that is 1 by V minus 1 by U equals to 1 by F. You have to find V. U is given, but F is not given. In this question F is not given, so you have to find F first, then you can calculate V for lens 1. Similarly for lens 2, you can find you have to find V, because due to for magnification, because you can easily find U, but to find V you have to find F. So first of all we are going to find F1 and F2 for these two lenses, that is for F1 for first lens and F2 for second lens, right? So using lens maker F1, which equals to mu minus 1, that is refracting index minus 1, into 1 by R1 minus 1 by R2. What is R1? R1 the radius of curvature of first surface. First surface means whenever light is fall first, so that surface would be R1, and second one is R2. So here whenever light goes like this and falls this surface first, then this is R1 and this is R2, right? So the value of R1 R2 is given, or for all the curvature, radius of curvature should be equal, but you have to put the value with sign, because sign convention is very important. So here sign convention method अलग अलग बुक्स में अलग अलग है, तो हम यूज़ करेंगे कि डायरेक्शन ऑफ लाइट अगर ये है, बिकॉज लाइट कमिंग फ्रॉम दिस ऑब्जेक्ट एंड फॉल्स इन दिस लेंस, so this is the direction of light. So we are taking positive in the direction of light. The length is positive in the direction of light and length is negative in the opposite direction of light. This is the positive and this is negative, right? So this is our sign convention, that we are taking positive sign in the direction of light, in the direction of light. If we measure any length in the direction of light, then you can take positive. If we measure any length in the opposite direction of the light, then you can take negative. So first just put over here mu value is 1.5 minus 1 into 1 by r1 is 20 and r2 is also 20, but with sign. R1 is positive or negative. First, this is r1, this is the center. So say this is the curvature. Curvature means if we draw it in a circle, so this is a cutting part of this whole circle, and say this is the center of this circle. Okay, so this length, imaginary length, say this length should be r1. So if I measure this length from this side, because all the length we measure from lens to this point, image distance or object distance always take from lens to this distance is u. We are just measure from this point to this. Suppose image distance is say here, so from this point to this, not this point to this. Okay, all the lengths we are taking from center point or from lens to that the given point. So here this is the center, so center of curvature is, sorry, radius of curvature is this point to this point. So this is the direction where we are going to this point to this. So this is the direction of light, because light direction is here. That is, say this is the positive x direction, right? This is our direction of light. So we are going to measure the length of the curvature, the radius of curvature. So this length to this center point to this point. So this is r1. So r1 should be positive. So r1 is plus 20, right? And for what about r2? So similarly, this is a circle, say this is a circle and this is a curvature, that a small arc of this circle. So say this is something the center of this curve. So this is the length of radius of curvature. This is the length of radius of curvature. So as we mentioned that the length should be from center or from the lens to that point. So we are going to this point to this point. So the opposite of the direction of light, right? This point to this point, the opposite of the direction, because direction of light is positive x direction and this is the negative x direction. If we take this is the positive x direction. Okay, so the negative, that means r2 is minus 20, right? You can take opposite direction also, because many books the sign convention is direction of light is negative and opposite direction is positive. You can apply it, but here you can just practice for one convention. Okay, that should be easier. Okay, so for my convention, that is direction of light is positive and opposite direction is negative. The direction of light, here r1 is direction of light, because this point to this point is positive and this point to this point, this is r2, that is negative, that is minus 20. So you have to put with sign convention, there is proper sign should be there, that is 0.5 into this minus minus is positive, that is 2 into 20, 10, that means 0.05 centimeter. All are in centimeter, right? R1, R2 are in centimeter. That's why. So 0.05 centimeter. This is our, sorry, this is not F1, because F1 is 1 by 0.05 centimeter. Because this is 1 by F1 value is given here. That is 0.05. So this is 20, right? Plus, because all values are in plus. So plus 20 centimeter. This is F1, right? This is F1. Okay. Now you can just find the value of F2, the focal length of this second lens, that is L2. Okay. Same formula, but you have to put all the values with sign, right? So same formula is 1.5, because refracting index for second lens is same. 1 is 1 by 20 and this is also 20, but with sign if I put, this is a R1, light is coming from this and going to this, so this is our R1, because light is R2, so this is R1 and this is R2. So for R1, radius of curvature should be in this side, and we are measuring from center to in this direction. This is the opposite direction of light, because light is goes towards this, and we are measuring from this point to this. This R1 is negative, and R2, for R2, there should be the circle, and the length should be measured from this point to in this direction, and this is the direction of the light also. So that's why this is R2 is positive. This R2 is positive. Clear? So R1 is negative, that is minus 20 in this direction, because we are measuring from this point to this, the opposite direction of the light, because light is goes towards x direction, positive x direction, and we are going to measure the length in this direction. That's why the opposite of the direction of light. That's why r is negative, and this is the direction of light, that is positive. So just put the sign, that is 0.5 into minus of 2 into 20, that is 10. The same calculation, 0.05, but this is the negative, that is f2, sorry, this is f2 for second lens. F2 should be minus 20 centimeter. 1 by 0.05, that means 20, and the negative sign, then the minus 20. So we are getting f1 equals to plus 20 centimeter and f2 equals to minus 20 centimeter, right? You have to calculate V. So just use lens formula for this. So just cleaning this portion. Now you have to find this is our object, right? This is our object, and light comes from this object in this direction. Okay. Now just think, this is f1. The focal length of the lens is f1. That means this is 10 centimeter, and f1 is 20. That means say this is the length, that is focus is here, and also another in this portion, that is say this is focus is here. Okay, the focal point, this is also another focal point, the 20 centimeter from this side, from the center of this lens, the left side of this lens and right side of this lens. Clear? An object is placed between focus and lens. Just think, object is placed between focus and lens, because focus is given, because we measure the focus, the value of focal length is 20 centimeter. 20 centimeter from where? From lens. So this distance is 20 centimeter, and object is given, that is 10 centimeter from the lens. That means object is placed between focus and lens. So light goes in this direction and is come and goes to like this, because it converts and towards the focus. It converts the light towards focus, and another light like this from the center of the lens in this direction. So if because these are divergent, like they never meet, these two light never meet. So that's why if I join it in backward direction, because in this, so we are getting like this, we are getting image. This is the virtual image, you know better. This is a virtual image, this is V, we can get, right? The diagram should be like this, but not this. This is not an original diagram for this system. Now we are going to find the value of V for this L1 only. You just think L2 is not present. Okay, you just think L2 is not present. With the absence of this L2, we can get the image distance V like this, because object is placed in front of first lens and in between focus and this lens. That's why we can get the image like this. Clear? So just find the value of V. So using the lens formula, 1 by V minus 1 by U equals to 1 by F. So 1 by F means for first lens, that is F1. Just calculate V. U value is given here 10 centimeter, but this 10 centimeter measure from this lens to this point. This is the opposite direction of the light. This is the initial lens. Opposite direction of the initial light direction. The initial light direction is positive x direction, and we are measuring distance from this lens to this in this direction, the opposite of the light direction. That's why U is negative, minus 10 centimeter. Just put over here, minus 10 centimeter equals to 1 by F1 is positive here, that is F1 is positive here, that is plus 20. So 1 by V equals to this minus and minus positive, and if I take right hand side, minus 10 centimeter, right, that is 20. The 1 minus 2, that is 1 by 20, but this is minus. So V should be minus 20 centimeter. V should be minus 20 centimeter. So our calculation is right? So V should be like this, minus 20 centimeter. That means V should be at focus like this. So this is our V distance from this point to this point. That's why it will come with sign is negative. That means lens to this direction. So this is our position of image, and this is enlarged image. This is a virtual image. So magnified image, you can get magnified image. So what is the magnification? Just write, pause the video and write. So the magnification value M1 equals to V by U. Just put over here, V value is minus 20 and U value is minus 10 centimeter and centimeter. That is 2. 2 is the magnification value. That means the image size is the double of the object size. Okay. Now M1, we are getting M1 which is 2. Now we have to find M2. We have to find M2. Now अब L2 लेंस पर लेकर आओ फिगर में, ठीक है. तो this is the image when L2, that is second lens, is not present in this figure, but now L2 is present here. Okay, so whenever L2 is present, so L2 क्या देखेगा? L2 तो ऑब्जेक्ट को नहीं देख रहा था ना. So for L2, now इसका काम खत्म हो गया, because for L1 this is object and this is image. तो L1 का पार्ट हो गया. Now we can find value of V for L2. For L2, you can just think, for L2 object is not this. For L2 object is this one, right? So for L2 object is this one, you have to find image or image distance. So what should be the object distance for L2? Because this lens is 20 centimeter, right? As this distance is 10 centimeter. So object distance is from this to this, that is 20 plus 10, that is 30 centimeter. So this is U equals to 30 centimeter for this lens. Because this lens के लिए ये तो ऑब्जेक्ट नहीं है ना. ऑब्जेक्ट क्या कौन है? ये इसका फर्स्ट लेंस का जो इमेज है वही सेकंड लेंस का ऑब्जेक्ट है. So the object distance is 30 centimeter. That means this distance is we are taking from this point to this, because all our distance we are taking from lens. So this point to this point, this is the direction, the initial direction of light, and this direction is opposite direction of this light direction. That means this is negative. So U should be minus 30, and F2 is also given. So just use lens formula, 1 by V minus 1 by U equals to 1 by F2. This is F2 for lens 2. So this is for lens 2, L2. Okay. So V, we want to find here V. We don't know U is minus 30 and F is minus 20. F2 is minus 20 centimeter, minus 20 centimeter. Unit not there. Now V, just calculate it. 1 by 20 plus minus 1 by 30. And this is also minus, which equals to minus common ले लो 60, that is 3 plus 2, that is minus 5 by 60. Now V equals to 60 by 5 and minus, that is minus 12 centimeter. So this is our V. So this is the V for second lens. For this second lens, V should be minus 12. That means like this position. Okay. Like this position. You can see. Okay, ऑब्जेक्ट को थोड़ा सा छोटा कर दो, ऐसे डाइवर्टेड हो जाएगा. बिकॉज कॉन्केव लेग क्या करता है? डाइवर्ट कर देता है. और एक लाइट को लेकर आओ, ऐसे और इसको डाइवर्ट करता है. तो इसको अगर पीछे से बढ़ाओ तो इन दिस पोजिशन यू कैन गेट इमेज ऑफ the second lens. So this is our image distance. So this is, we are getting 12 centimeter, and that is negative because we are measuring in this direction and light is in direction, because this is the initial light direction. And always measure for initial light direction. Okay, diagram is clear. थोड़ा सा messy but it's okay. Now V is 8. Now we can get Magnification for second lens, magnification मतलब V by U, V is -12 and U is -30. All are positive because object is erect, that's why, not inverted, that's why these are positive, minus positive. And 30, 12, 30 is a 4 and 10, 4 by 10, or you can do 2 by 5, right? So 2 by 5 is the value of M2. Now the final answer, the total magnification of the system. The total magnification, you already mentioned the formula, M equals to M1 into M2. M1 into M2, M1 is magnification for first lens is 2 and magnification due to second lens is 2 by 5, that is 4 by 5, that is 0.8. So 0.8 is our right answer, that is option B, 0.8. So this, due to this L1 and L2, this is the generating a system, and for this system magnification should be this. Clear? Okay, so let's go to our next question. Okay, next question. A heavy nucleus Q, so nucleus is Q, of half-life is 20 minutes, undergoes alpha decay with probability of 60%. The probability of alpha decay 60% and beta decay with probability of 40%. ओके, सो ये अगर डिके कर रहा है तो प्रोबेबिलिटी है कि अल्फा डिके होने का प्रोबेबिलिटी है 60% फॉर अल्फा डिके एंड 40% फॉर बीटा डिके. ओके, इनिशियली द नंबर ऑफ Q nuclei is 1000. 1000 was the number of nuclei of Q initially whenever decay is not started. The number of alpha decay of Q in the first 1 hour. So the time is given, that is 1 hour. The first 1 hour, the number of alpha decay, the first 1 hour is, तो कितना नंबर अल्फा डिके हो जाएगा, कितने नंबर ऑफ न्यूक्ली का अल्फा डिके हो जाएगा. तो फर्स्ट ऑफ ऑल वन थिंग इज गिवन, ओनली द नंबर ऑफ अल्फा डिके पूछा है, तो सिंपल हम लोग कंसंट्रेट करेंगे कि अल्फा डिके कितना हुआ है. ठीक है, तो ये 40% का मतलब कुछ भी नहीं है, सिर्फ इसको देखो कि 60%, द प्रोबेबिलिटी ऑफ अल्फा डिके इज 60%, राइट. So 1000 the total number of nuclei initially, so the probability is 60%. That means 1000 into 60%, that means 600 is ready for alpha decay. 600 nuclei is ready for alpha decay, that is our N naught, right. So we are not concentrated here for beta decay because 40% is beta decay, the probability is 40% of beta decay, but 60% only here the number is given, number is they asked the alpha decay is for alpha decay. So we are just concentrated on this because out of 1000 nuclei 600 is ready for alpha decay, not beta decay. Only alpha decay is ready for 600, that is our N naught. Now the half life is given is 20 minutes. The first 1 hour, that is T is given, that is for first 1 hour the number of decay, first 1 hour. So first 1 hour, just think for 1 hour the number of half life, because one half life is 20 minutes, T half is 20 minutes, right. इसका मतलब क्या है कि 20 मिनट में जो न्यूक्लियाई का साइज था वो हाफ हो जाता है, डिके करके हाफ हो जाता है. तो फॉर 1 आवर द नंबर ऑफ हाफ डिके इन 1 आवर द नंबर ऑफ हाफ लाइफ से n which equals to T by T half, that is 1 hour, that is 60 minutes divided by 20 minutes, that means 3. Number of half life in 1 hour is 3 because one half life is 20 minutes and in 1 hour number of half life is 3, right. So इसका मतलब क्या है कि for first half life the number should be half, the initial number should be half for after one half life. After 2 half life this number should be half, this 2 into half, that means N naught by 4. After third half life this number should be half, N naught by 4 into 2, that means N naught by 8, and so on. So we can get a general formula for n half life, for n half life And the number of undecayed nuclei should be what? N0 by 2, sorry, N0 into 1 by 2 to the power n, where n may be 1, 2, 3, 4, because whenever n is 1, that is N0 by 2, you can get here N0 by 2. For n equals to 2, n equals to 2, 1 by N0 into 1 by 2 to the power square, that means N0 by 4, right? So you can get this. For n equals to 3, 2 to the power 3, that means 8, so N0 by 8, and so on. So this is our general formula, you have to remember this. So here n is given, that is 3, right? So after 1 hour, number of half-life is 3, that means the undecayed nuclei remaining, that means N0 into half to the power 3, that means N0 by 8, right? So what is this N0? This N0 is initially which are ready to decay. Initially ready to decay for what? For alpha decay. So initially we can get initially ready to decay for alpha decay is 600, because total 100 is not going to decay for alpha decay. So for alpha decay case, N0 should be this 600. So just put over here 600 divided by 8, that means that is 75, right? 600 by 8, that means 75. So this the number is remaining, that is undecayed nuclei. Okay, this 600 is ready to decay alpha, but after 1 hour, because in 1 hour number of half-life is 3, that's why the undecayed nuclei in this portion is 75. So the number of decay, very easy, number of decay, that is alpha, which equals to 600 is ready to decay alpha, and 75 is undecayed, that is minus 75, that is 525. So this is the number of Q, they are decayed alpha, right? The alpha decay is, number of alpha decay is 525. So D is our right answer. Clear? That's all. In this video we covered section 1 in paper 1. These are the 4 questions we have discussed. So next part we'll discuss another section, that is section 2. Okay, so stay tuned, and for further information, for further any query, you can go to our description box, where you can get the link and also as the phone number. You can directly call us to join our classes, and you can go our website. So I hope you enjoy this video, and for any doubt, any question, you can write in the comment section. So we'll meet in next video. So thank you so much for watching this video.